Hello everyone, welcome to my channel. Today we are considering a topic, experimental reports and grading. We're having this topic this time around, especially when we're preparing for NECO practical exam. As we all know, in our exam, we are going to have paper 1 and 2, which is subjective and theory, and paper 3, which is practical. And this practical carry at least 35% of our total score. This practical will carry at least 35% of our total scores. And in a practical, you'll be given 3 questions. You'll be asked to answer 2 questions out of 3. And each question carries 50 marks. What are the things that we look at in all these practical questions? When you are asked to perform experiments, you'll be given the list of apparatus to be used, and the procedure will be given on how to set up the apparatus and carry out the experiment. And you'll be asked to report your experiment. The first thing you report in the experiment is observation, what you observe when you follow the procedure and carry out the experiment. And this observation carries 8 to 10 marks, depending on the number of values that you have to record or number of evaluations that you have to carry out from the experiment. Now, this observation is divided into 2 segments, which are constants and variables. Constants are recorded with their corresponding unit on separate line in your answer booklets. Constants are those parameters that will not change throughout your experiment. That is the parameter that will remain the same, like probably the center of gravity in a moment of force about a point, or probably the number of oscillation in a simple harmonic motion experiment. We refer to all those things as constants in most cases. Now, variables are those things that will change with each other when you are performing your experiment. And variables are usually recorded in trend in a composite table. With the unit of each quantity stated in the first row of the column containing the quantity. And we can see that on this table. As you can see this table on the screen. You can see the columns. At the top of each column, we have the parameters and their units. We have the parameters and their unit. Like on the first column, we have the parameter h with the unit centimeter. Also, on other columns, we have the parameters and their unit. This unit, we can put it in bracket by writing at h bracket centimeter, that is h is measured in centimeter, or we can as well say h slash centimeter, that is h is measured in centimeter. Now, where can a student incur loss of mark while presenting observation on the table? Let's quickly consider that. I will come back to this table. Okay, now let's see. First thing that can make you to lose part of your 8 to 10 marks is when you have wrong or a unit is missing from the table. This attracts half marks each. Though wrong or missing units for 2 or more columns in a table having the same unit attracts loss of a mark only. Okay, let me quickly explain this. Now, as you can see on this table, we have like 2 columns having the same unit, that is this column and this column. They're having centimeters at their unit. And please, I want to beg you, don't make a mistake of writing unit in front of each of your value. Like in this case, this is very wrong. Writing centimeter like this is very wrong because it's common to some students. Please don't make these mistakes. Once you have your unit written at the first row of every column, it is okay. Now, what we are saying is that instead of putting centimeter here, you now put something else like seconds or any other unit that is wrong unit. You're going to lose half mark. And if you do the same thing here, you still lose just half mark because they have the same unit. And you can see in the case of a time and a period as well, if you put the wrong units, or probably the unit is even missing, probably instead of putting seconds there, you refuse to put anything there, or you just leave it as T or capital letter T alone. That is a missing unit, and that is loss of half mark as well. Okay, What other thing do we need to look at here? Okay, inconsistent significant figure or decimal place attracts a loss of half mark per column up to a maximum of 1 mark per table. What do I mean by this? Okay, what do I mean by inconsistency? As you can see from this table, all the values on these columns are recorded to the same place of decimal, that is one place of decimal, and the values here are recorded to one place of decimal, while the values on this column are recorded to 3 places of decimal. Okay, let's say while you are reporting, you have this one recorded to 2 places of decimal, while others are left in 1 place of decimal. That is inconsistency, and that will bring about loss of half mark. And if this occur more than once on a table, it means you can only lose 1 mark on that particular table. That is what the instruction is saying. If it occurs more than one time on a table, you are only losing 1 mark. That is, in case of this particular region, you are supposed to record to 3 places of decimal, but you have one of them to 4 places of decimal. That is loss of half mark. Now, to know the number of decimal places to record all these two, I will recommend a particular book at the end of this video that you can consult to know the degree of accuracy of all the parameters that you'll be dealing with in physics practical. So what other thing do we need to consider here? Now, another thing that we need to consider is that when a candidate invents values different from expected experimental value, it is treated as gross error, and all calculations from such values under observation and graph will be awarded 0. Now, what is the meaning of this? Some candidates, they are fond of going into the hall and just get values from wherever or whoever they can get this from and just present it on the table. Now, this is in most cases referred to as a gross error, because if your value does not correspond with what you're supposed to have based on the procedure given in the experiment, it will be tagged as a gross error, and every calculation that you use these values for will be awarded 0. And there's something I mentioned right here, that is variables are usually recorded in trend and in a composite table. Let me quickly talk about that before moving on. What is trend? When we talk of trend, let's say you are to vary this L with 20 oscillation and record time for that. Now, in each of the value of L, that is when L equal to 130, maybe you have a 47.3 as your time for 20 oscillation. When L is reduced to 110, you have 43.1. You can see the trend. When L is reducing, capital letter T is also reducing. So that is a trend. But in case of your own report, because this L and T, they have a relationship. Maybe in case of your own report, you now have something else. Maybe when your L is reducing your own time, when your L is moving down, your own time is moving up. That means your values are not trending. Your values are not trending, and that is a serious mistake that you can have in any observation. That is a very huge mistake. So that is what we mean by trending. When we say something is trending, it means that they follow the direct relation, because whenever we are performing an experiment, we want to establish a fact about the two things we are varying. Probably they are directly related, or they are inversely related, or there's another relationship between them. That is what we want to establish. Okay. Now, when we talk of composite table, this one is 1 mark in every experiment. And what is composite table? When you have your table drawn in this form that you have here, this form of table here, we call it composite table. Now you can see all your values, all your parameters arranged in order and with their corresponding units at the top of each column. That is a composite table, and the composite table is a closed table. It's not a table that you just have something like this and you record just like this on a table. This one is not a composite table. For a composite table, you must have a close, that is the headings must be separated from the body of the table. That is what we refer to as composite table. And once we have this in our experiment with everything well recorded, you have 1 mark separately for composite table. So that is part of your 8 to 10 marks. Okay, let's move away from observation Now, the next thing to consider is graph. In your experiment, in most cases, they will be asked to plot graph of one parameters against another. And graph carries 6 marks. It carries 6 marks. Okay. Now, what are the things that we need to consider while plotting graphs? We must have our axis correctly labeled with names and units of the quantity being plotted, not using y and x, because in physics you have quantity, a known quantity that you are plotting, not y and x that we normally use in our mathematics because we are referring to unknown. But in physics, we are plotting known quantities. So you have to use the name or the symbols of the quantity you are plotting with their corresponding units. And also, you must choose a reasonable scales that will make your graph to at least occupy 2/3 or 67% of your graph sheet. Listening to this again, you have to choose a reasonable scale that will make your graph to occupy at least 2/3 or 67% of your graph sheet, and always avoid the use of prime numbers and some strange odd numbers. Okay, now in your graph, before you can plot any graph, you must have at least 5 to 6 points before you can plot a graph, and you have to plot them correctly. You have to plot them correctly, following the rules in plotting graphs. And also you have line of best fit. Let's quickly consider some of these on the graph that I'm going to show below. As you can see, there's a graph on the screen. Now, the first thing we are considering on this graph is the scale. You can see how the scale is written. The scale is always written at the top right hand corner of your graph, not the other way around. You can see the title of the graph on this side, that is top left hand corner, not the other way around. Your scale must be at the top right hand corner, while your at the top right hand corner, while your title is also at the top left hand corner. Take note of that. Okay, now how do you present your scale? Let me quickly explain something from this graph. Let's look at the graph from the beginning. You can see the origin of the graph. This origin is represented with 0, 0. And between the origin and the next value here, we have from 0 to 2. And between the next value and the subsequent one, we have 2, 2 intervals. So now, how do we now find our scale? Between 0 and the first value, we can see 10 holes, which represent a box. And on our graph, we have 2 centimeters for each of the boxes. We represent them with 2 centimeters. So which means for this particular graph, 2 centimeters, which is a box here, represent these 2 units that we can see here. Let me show it again. 2 centimeters, that is a box of 2 centimeters, represent these 2 units that we can see here on this particular axis. And on the horizontal axis, we can see that these same 2 centimeters represent 1 unit. So how do you present that? Now, before presenting that, you look at what you use to label your graph. That is on your x-axis, because the title of the graph says we have to plot voltage against current. So on the x-axis, we have I, which is the symbol of current with the corresponding unit written there. And on the vertical axis, we have V, which is the symbol of voltage written there. So how do we present our scale? On voltage axis, we have 2 centimeters representing 2 units. So we can say 2 centimeters represents 2 units on V axis. Please avoid the use of Y axis. Few examiners may overlook it. Why majority of our examiners will not overlook it? Because we are dealing with known quantities, which we have to use their symbols or their names. On the horizontal axis, we have a 2 centimeters representing 1 unit. On current axis, that is I, and the unit of current is ampere, as you can see there. So now we also talk about line of best fit. What is line of best fit? Line of best fit is a straight line drawn to pick at least 3 out of our 5 plotted points or 4 out of our 6 plotted points, while the remaining 2 are evenly distributed on either side of the line. Sometimes your line of best fit can pick 2 out of your 6 plotted points, leaving the remaining 4 distributed on each side of the graph. Now, evenly distribution, let's quickly talk about that. When we say even distribution, now look at the graph here. You can see the line is able to pick 3 points, and the remaining 2 points are distributed on either side of the graph, having almost equal distance from the line. That is even distribution. It's not that one is here while the other one is here. This is not even distribution at all. So, and this line of best fit carries 1 mark out of your graph. Your scale is 1 mark. Your labelings, that is labelings of vertical and horizontal axis, carries 1 mark. Line of best fit carries 1 mark, making 3. So, though in some cases you may draw a line of best fit through your plotted point, while all the points are evenly distributed evenly along the line, very close to the line, you can make that as your line of best fit. But in most cases, we do have it picking 3 out of 5, leaving the remaining 2 on either side of the line, evenly distributed, or 4 out of 6. Okay, that is line of best fit. And the last 3 marks for your graph is correct plotted points. When you plot your point correctly, you're going to have 3 marks for that on your graph. Okay, let's look at another thing to be considered while reporting practical. You may be asked to determine the slope or the gradient of the graph. Okay, when you're asked to do this for a straight line graph, your slope may be positive or negative. Positive in the case of this figure, 1.2a, and negative in the case of figure 1.2b. Okay, now how do you now determine your slope? For a straight line graph, if this is the line of your graph, the line of best fit of your graph, pardon me, if this is the line of your best fit, now if you are to calculate the slope, you have to draw a right angle triangle, as you can see here, on the line, having the signs of this right angle here. Very, very important, because without the sign, an examiner may just assume that you are drawing any type of triangle, which is not right angle triangle. Please take note of that. Now, the right angle triangle must be reasonable in size, not a very tiny right angle triangle, like some students will just draw something like this. No, this is too small. So it must be reasonable in size, as you can see on the screen. And the values are to be taken, that is the change in y and x-axis will be taken. As we can see here, the change in y is taken by subtracting the value here from the value you are able to pick here. So that is change in y. So the formula for your slope equal to change in anything that you have on the y-axis. If you are plotting footage against current, you have change in v over change in I. Please avoid the use of x and y once you have the names of the quantity you are plotting. Okay, the change in x-axis will be picked from this place. That is, you are subtracting this one from this one to have your change in horizontal axis value. And with that, you have the value of your slope. So this triangle carries half marks. If you draw it with this sign, it carries half marks. Most times some examiners will overlook it, but while some will not overlook it. So always remember to put the sign. That is half mark out of your 2 marks for the slope. And if you are able to, if you write out your formula, you have another half mark. Though in some cases, if you have a correct substitution without formula, the mark for the formula will be added to your substitution mark, making 1 mark. And the final answer after evaluating your value is also half mark, making the 2 marks. But in the case of this second graph here, in the case of this, you may end up having negative slope because the value of your x2 is less than the value of your x1, as you can see here, because x2 comma y1 is picked from this corner of your right angle triangle. So you may have negative slope, and most time the negative in front of the value of your slope only represents, only talking about probably direction or relationship of one parameters to another. Okay, moving away from slope, what is the next thing that we need? Okay, before moving away from slope, if in the case of your own graph, you are asked to use a smooth curve to pick your point, and you're asked to calculate the slope as well, what you just need to do is draw a line that is tangential to the curve. As you can see here, this line is touching the curve, so that's why we call it tangent to the curve. And on that line, draw your right angle triangle and follow the same procedure as you did to straight line graph, and you will have the value of your slope. So to avoid the loss of marks, make sure your right angle triangle is having a reasonable size and the right angle sign is shown there, and also read and record the value of change in vertical and horizontal axis correctly. The next thing we are looking at here is intercept. What is intercept? Now, on your graph, you may be asked to find the intercept of the graph on a particular axis. Now, intercept is a point at which the line graph crosses the required axis. Let's say you are asked to find your intercept on vertical axis. As you can see, this is a vertical axis. The intercept of, let's say, this, if this is your graph, the line of your graph, the intercept on vertical axis is this point, and it is positive because it's picked on positive y-axis. While the intercept on horizontal axis will be negative because it's this point. So your intercept, while recording your intercept, what you need to do is indicate the intercept on the graph by showing with your pencil like this, that is up marks, and recording the value. If the value is 2 votes, recording it will give you another half mark, which makes 1 mark of your intercept. But some examiner may overlook what you put here if you fail to put it, in as much that you can record your value correctly, while some will not overlook it. Please take all this into consideration. Now, if this is the line of your graph, your intercept on horizontal axis is here and it is positive, while your intercept on vertical axis is here and it is negative. That is all about intercept. Okay, moving away from intercept, we have precaution. In every experiment, you'll be asked to state at least 2 precautions, and this goes for 2 marks. And when I start discussing the practice exercises, I will give the likely precautions that each of these experiments will have. Okay, now below the practice exercises for NECO 2023, and in question number 1, we may be looking at something in the region of mass spring oscillation from the report we've gotten so far. And for mass spring oscillation, we may be determining the acceleration due to gravity of a particular location. And here is the list of apparatus given. We have the list of apparatus here, so we'll be given a procedure, but we can use this question to just practice, because this experiment is a common experiment, so we may use this question to practice and see what we can do with this. Now, this is a diagram for the experiment, and we have to set it up like this. We are familiar with everything in this diagram. We have a rotor stand, meter rule, helical spring, and the slotted masses. We have to carry out the experiment, setting the mass into oscillation, taking the time for 20 oscillation, calculating a period, and plot a necessary graph. We'll be asked to plot m against t square, and find the slope of that, and derive and evaluate our acceleration due to gravity. Okay, what are the likely precautions for this particular experiment? In any simple harmonic motion experiment, you may state that you avoid conical oscillation. But one thing that is important in precaution, because precaution is a safety measure taken during your experiment. You are taking the safety measure, so you have to report it in the past tense form. So that's why you have it here that I avoided conical oscillation. You are not giving instruction. It's not that you are going to record it in form of instruction. So why writing your precaution, please record it in form of what you did. I avoided conical oscillation, and this is a general precaution for all simple harmonic motion experiments. The second precaution, which is general for almost all the experiments, I ensured that I avoided parallax error while taking measurements from the stop clock. That is, you can avoid parallax error while using any analog equipment like our voltmeter, ammeter, even meter rule, and our analog stopwatch. But mind you, when you are recording the value of your time to 2 places of decimal, be careful while using this precaution, because when you record your time to 2 places of decimal, probably you are telling us that you use a digital stop clock. Because those that will mark this, they are very, very smart. So when you record your time to 2 places of decimal, you may not be able to use these um, precautions. Be careful with that. Okay, let's move away from this and go to experiment number 2. From what we've gotten so far, our experiment number 2 may be in line with a refraction through rectangular glass prism, and we have a practice question here that we can practice. We have the list of apparatus here, and the procedure on how to carry this experiment out. We can practice this particular question with the supervision of our teachers. Our teachers will guide us on how to do this, though they may not help us to do it because we need to know it by ourselves, but our teachers will guide us to carry out this experiment. And we have so many things that we can discover or deduce from this experiment. And after a deduction, we may be asked to plot any graph. We may be asked to plot sine theta on vertical and phi on horizontal. Or you may be asked to plot d, which is deviation from original part of the ray, against the angle of incidence. And what are the precautions for this particular experiment? You can state that you ensured that the pins were vertically erected or the pins were reasonably spaced. I ensure that the pins were vertically erected, or you can say I ensure that the pin were reasonably spaced. When you are using the word reasonably spaced, it must appear on your tracing paper. The reasonable spacing must appear on your tracing paper. Take note of that. And you can as well state that I ensure that I avoided parallax error while taking measurement from a protractor. The use of I avoided parallax error. Please always add the apparatus to the statement so that the examiner will know the apparatus on which you are avoiding the parallax error, so that the examiner will be able to determine if you can truly avoid parallax error on the apparatus. Okay, now let's go to the third practice exercise. This is the only question that is not really common in this year's NECO 2023. Okay, but I want to believe we'll be asked to verify Ohm's law in this experiment with the list gotten so far. And if you follow this procedure, you can carry out this procedure using any of these two circuits. Now, the reason why we have two circuits is that we have a light bulb which can be connected to our resistance box either in series or parallel, because the two are serving the purpose of loads. So that is why we have this first and the second setup. You can try any of the two or try the two. You can see here bulb is connected in series to our resistance box. We have our rheostat here, and the function of rheostat is to adjust the current in the circuit. You may be given instruction to use the rheostat to adjust the value of current on ammeter to a given value, or probably to a maximum value, while we vary the value of resistance in the resistance box. And also you may be asked to comment or write something on the behavior of the light bulb while the experiment was while you were performing the experiment. These are the things we need to consider here. And in this second one, we have our light bulb connected parallel to our resistant box. Okay, now we can follow this procedure and carry out this experiment. And we have the two precautions for this particular experiment, which are the general precautions for any electricity experiment. As you can see on the screen, I ensure that the cell terminals were clean. This is a general, or we ensure tight connection of component. It's a general precaution for electricity experiment. And the second one, I ensure that keys was open when reading were not taken. This is also a general precaution for electricity experiment. And all the information we've given so far in this video is coming from a particular book that I mentioned. That is, I mentioned at the beginning that if you want to know the degree of accuracy of all the parameters, the number of decimal places you have to record them to, you can just try and get a copy of this practical book, Reform Physics Practical Book. It's available in the market, or you can as well contact the number displayed on the screen. The book is in use already in so many schools in Lagos State. It's in use in more than 10 schools in Lagos State and some schools in neighboring state, Ogun State. Okay. All this information that we've presented so far in the video is coming from this book. So you can get a copy of this book, and the book is designed to have close to 60 practical exercises in physics. In addition to our regular exercises for school candidates, we have alternative to practical for GC and NECO GC candidates in this book. Also, we have practical exercises for students preparing for Cambridge IGCSE also in this book. And this book is designed like a workbook. Once you have a copy of this book, you don't need to buy a graph at all. What you just need is your pencil. You can write your report. The space to present your report and to draw a graph is already in the book. In case you need a hard copy of this book, please contact any of the 3 numbers displayed on the screen or the email address. Or probably you need a soft copy of the book. You can see that on Amazon. You can follow the link also appearing on the screen here to get the book. And with that, we come to the end of this discussion. Thanks for watching.